Alright, here is an example from your textbook, and it is a basic mole to mole Stoich problem. Alright, it says if 5.50 moles of calcium carbide, CaC2, react with an excess of water, it means there is more water than you need for the reaction, how many moles of acetylene, C2H2, will be produced? And then it gives you the balanced equation. I know it's a balanced equation because there aren't any blanks out in front of it for me to balance it, and you can double check to make sure it's balanced. Now, the steps of stoichiometry. Step 1 is convert to moles. But we already have moles, so I don't need to do step 1. Alright, I'm just going to write down my answer, which is 5.50 moles of CaC2. Alright, step 2, mole ratio. Alright, mole ratio, I have 5.50 moles of calcium carbide. That's what I'm starting with because that was my finished part of step 1. So I'm starting with this, and if I have moles of calcium carbide, I'm going to put the known substance, the substance I know, which is moles of calcium carbide, on the bottom, and the substance I'm looking for, which is acetylene. So I'm going to put moles of C2H2 on top. It's called a mole ratio because I have moles on top and moles on bottom. It is a ratio of moles. Now the numbers that I put here come from my balanced equation. I have calcium, CaC2, calcium carbide. The coefficient is 1, so I write a 1 there. Remember, we don't write the 1 when we balance the equation, but it's there. The coefficient of C2H2 is also 1, so I write the 1. So my moles of calcium carbide cancel. I'm left with moles of acetylene. Step 3, so I multiply this out actually, sorry. That gives me 5.50 moles of C2H2. Okay. Step 3 of stoichiometry is convert to the desired unit. Well, the desired unit is moles. It says how many moles of acetylene will be produced. Well, I already have moles, so I don't have to do anything. And that is a basic mole-to-mole stoichiometry. If it's moles to moles, then you don't have to do step 1, you don't convert to moles. You don't have to convert to a desired unit because your desired unit is moles. All you need is the mole ratio. The mole ratio is the most important part of stoichiometry. The mole ratio translates from one substance to another. So you can think about it as this person is speaking Spanish, this person is speaking French. You have to have a translator translate from the Spanish to the French. That's what your mole ratio does. It translates one substance into the other using your balanced equation. This is like your Spanish to French dictionary. You have to use this to translate it. Alright, so there you go.